Excellent. So we're keeping it rolling on Saturday. Hope you guys are enjoying the talks. We got a great talk coming up from the CTO of Mimic Protocol, Facu, and he's going to be talking about scaling Ethereum development. So round of applause.
Testing. Can you hear me fine? Yeah? Okay. So we're here today to talk a little bit about how we think we can scale Ethereum development through trustless automation. So yeah, my name is Facu. I'm the CTO of Mimic, and we've been working in the industry for a while, mainly pushing for automation in this space. I would love to tell you a little bit about my background. I started working as a blockchain engineer in OpenZeppelin in 2017. Then I joined other projects like Aragon. I helped building Balancer V2. I also been contributing to the graph. It's been a great journey until we got here. And something that I kind of realized in all these projects that I've been working with is that automation is something that it's always saved for later. You always take care about architecture, security, smart contracts modeling, a lot of critical details for your protocol, but at some point, all of these rely on some sort of automation that you need to take care of. But this is simply procrastinated. This is definitely an endless cycle. It's something that you push forward for future iterations, and at some point you need to take care of it. The thing is that you don't put too much effort into it. You don't think this is a critical part of your project, but I think it is. And at the end of the day, this ends up being a huge waste of time for the devs. The thing is that automation is critical for both the devs in a project, but also for the users. You can expect users to be interacting manually with projects, so this is heavily and critical. Let me tell you a little bit about what we have seen during these years in all the projects that we've been working with. Of course, mainly repeated processes, like tons of teams doing manual things once a week, once a month, repeated tasks that they need to take care of manually, and there's no common way of doing things. This is a huge waste of time. Also manual intervention, like gathering a group of people so they meet in a war room to review stuff that they need to take care of. This is definitely error prone. Also at some point they realize they start like doing the same thing many times, so they start building custom scripts to take care of that. The thing is that these kind of snippets are unmaintainable. No one follows like a common pattern in order to build this, and at some point you start it starts growing. A few guys in the team know about this. It starts being a huge mess, definitely. Also relying on private data sources, like all these pieces of code at some point need to rely on on-chain data or off-chain information like prices or information about the protocol, whatever. The thing is that this ends up being unreliable. There's no decentralized way of accessing this data, and it ends up being a single point of failure. This is probably the most critical ones. These scripts at some point needs to do some transactions. They need to do something on chain. They need to sign things. So we heard like a lot of people storing these keys in servers, and well, we know about a huge hack that we had the last couple of days about the server that has been compromised. What we would love to see instead is mainly standard processes. There should be a no-brainer way of doing things. When you come up with the idea of automating something, there must be a standard way of doing things. This needs to provide low-level abstractions. At the end of the day, you need to interact with chains, with prices, with information, with a lot of things that you don't have to reinvent the wheel, right? These standards, this tooling needs to abstract you from all of that. Trustless data sources. At the end of the day, this data that you are accessing in order to automate whatever you're doing in your protocol, it's something critical. So there must be a good data availability for that. Decentralized execution as well. At some point when you need to perform some transactions on chain, you just want that to be executed. You don't want to deal with something that it's been stuck or something like that. So being able to rely on a network, decentralized network, to execute something, it's a good way to just forget about it. Proper access control, again, we are always dealing with some critical concepts of your protocol or having access to different parts of it. So it's critical that we have a good way of controlling access for it. And finally, monitoring tools, which is sounds simple, but it's critical as well. You can build a great solution, but if you don't know what's going on behind the scenes, if it's working well, if it's getting stuck, you need to have like dashboards, metrics, logs. This is a really important thing as well. This would be amazing, right? If we have a single way of doing all this, if there's a common tool or protocol that we could use, it would be such a great thing. The fact is that there isn't. And this is what we are calling trustless automation. We've been pushing this for a while during the last couple of years, and we have a lot of evidence of what have helped other users and what's not. And I would love to take you to tell you a little bit more about it. So, going back a little bit, how we got here. I remember in 2022 when we started working with some projects in this space like Decentral and Paraswap and other protocols. We started building simply on-chain recipes. This was okay because it was an easy way to interact with our protocols. We started using on-chain oracles. That was fine. I mean, we were kind of forgetting about accessing data in a reliable way. There was reinforced security, of course. Like everything was written in smart contracts, so there was no doubt about what was going to happen. But the thing was that it was really hard to change. If the user wanted to tweak some variables or configurations or something related about what that code was doing, they had to ask us. We need to implement that, deploy to the all chains that we were going through, and it was not an easy thing to do. So then we came up with the idea of start extracting these configurations to be customizable by our users. So mainly they started being able to control thresholds, for example, like, okay, I need to use these balance thresholds to trigger this or these actions in the chain. Also time logs, users were wanting to be able to control time, like when things need to happen, like once a week or once a month, or everything related to time, of course. Also volume limits, they wanted to control which is the amount of volume that was going to be processed through these actions, like, okay, I don't want to process more than 100K a month, whatever. Also access control, like who is going to be able to tweak these variables in the team. So we need like a permission layer built in. They wanted to also control like network congestions, like if something's going on in the chain that is being raising the gas price, maybe they wanted to act in a different way. So they wanted to control these limits as well. The thing was that it was really cool, but we still were very, very highly coupled to protocols. All these integrations were built on chain, and it was again not that flexible if they wanted to like plug things in and out. If they wanted to, I don't know, start using another aggregator or another protocol to do some sort of things, it was not easy. They have to ask us to build those integrations and deploy them. And this is where we came up with the idea of the Lego pieces. Mainly, this was what we call the protocols connectors. There were some sort of plugins that they could play with. So every time we integrated a new protocol to our stack, that was super easy for them to plug them in and out if they wanted to try it. It allowed us to define standard tasks around it. That was a great thing, especially for the relayers, because we could build a common logic about how these tasks needs to be executed. There was a common language between them that was really good. And also it started allowing users to model complex things. These Lego pieces were able to be connected between them, and it was super easy to model like complex solutions that they wanted to automate. The last thing is that they are still dependent on us. Like, even though the stack that we built was open source and it's public, at the end of the day, they were handling like critical things, and they were dependent on us, like having our support in order to deploy those solutions and much more. So the good thing is that we definitely validated the idea. We processed like 4 billions in terms of USD of automated value. We work with this list of top-tier projects in the space. As you can see, even the big ones are requiring this type of solutions. But now what we want to do is basically to open the game, like decentralize what we're doing, open it more so more devs can come and build their own solutions. Why? Because mainly we're still receiving a lot of requests of developers or teams that are willing to automate things for their own projects. But the thing is that we cannot take care of all of them at the same time. So we need to scale more. And definitely decentralizing and open up these standards are a good way of doing it. There's definitely no solution in this space. Like if they wanted to take care of all the things that we've been saying before, there's no easy thing that takes care of all that. And definitely the community needs to be pushed with good standards. There's going to be like huge challenges as well. Finding a standard way to model everything that we've been saying before, data sources, related executions, monitoring tools, everything related about automation is not easy to define the standard, because mainly developers want to automate like custom stuff. They want to create their own ideas that they want to automate, and this is not easy to define like a common way of doing things. At the same time, guaranteeing a good developer experience, that's going to be a huge deal. And even if we find some adoption and we validate the product market fit with these solutions that we've been building, decentralizing that is going to be a huge challenge as well, while keeping that adoption. So I would love to tell you a little bit about how Mimic Protocol is going to work. This is the name that we are giving to this protocol, of course. Mimic Protocol is going to be a 3-layer protocol, and let me tell you some details about how each of these is going to work. So the first one is the planning layer. This is basically probably the huge deal here. It's what allows devs in the space to define their own tasks. Tasks are implemented in programming language. These tasks are being compiled into WASM, which is going to be executed by the relayers. So this layer will basically provide both things, access to the relayers to take care about the execution, but also to the oracles. They're going to be able to access this data that they are needing for the task in a decentralized way. And of course, they will not just define what the task should do, but also the triggers, what triggers them. It could be an on-chain event, it could be a balance threshold, it could be some sort of cron schedule, whatever. The next layer is the execution. As I was saying before, since tasks are compiled into WASM and this is going to be executed by the relayers are going to be the ones interacting actually with the chain. And if we need to send transactions, we cannot, of course, delegate access to our private keys to the relayers. So this is why we are leveraging the concept of intents here. The good thing is that users don't need to take care of how things are done. They just need to tell what they want to do, and we can leverage the whole architecture, the whole infrastructure that the community is building for solvers in order to take care of that. The good thing is that always the best proposal will win, so users won't be harmed. And the last one is the security layer. This is basically where we guarantee on-chain that whatever the user wanted to do is being done. Otherwise, it gets rolled back. Mainly, we're using settler contracts, which is the backbone of the intents idea. And we're introducing a new concept here, which is optional for users, but it allows them to define on-chain conditions that they want to make sure that are met before everything gets executed. This is what we call safeguards. So in a sense, we do need this. We want to push these standards for the community. Our goal with this is to provide, again, a common way of doing things, something that abstracts you from all the critical things that you need to take care of when you're dealing with automation, accessing data, related executions, a great developer experience, monitoring tools, and much more. So we're here to push for this. If you're interested in learning more, we have tons of technical details in our documentation. You can access the white paper, which is a really good piece of information if you want to read more about the math behind it, incentives, the architecture, the security measures that we're taking. It's great if you want to come and learn. So thank you, folks, for hearing me today. Hope you enjoyed the talk. And well, there you got my Twitter or GitHub accounts. If you want to get in touch with me, feel free to drop a message. I'll be more than happy.